Have you ever watched one of those massive mixer trucks at a construction site and suddenly noticed fresh concrete pouring out of its giant spinning drum? It makes you wonder exactly what's happening inside that constantly rotating metal barrel. But even more interesting, how does the whole complex system actually work? Don't worry, because in this video, you're going to discover exactly what's inside that mysterious drum. You'll also see the complete, fascinating process of making concrete from scratch, the different types of mixers used around the world, and the strict tests the concrete has to pass before it can be safely used on a job site. So get comfortable, get ready to be amazed, and pay close attention, because what you're about to learn is going to blow your mind. But before we dive into this awesome journey through concrete engineering, if you love educational content about heavy machinery and construction, smash that like button and subscribe to the channel so you never miss more videos like this. All right, let's get started. First things first, loading the truck with fresh concrete. So let's see exactly how concrete is made right from the beginning. But this isn't just any regular concrete. It's a special ready-mix concrete that goes through several careful processes inside an industrial batching plant. The foundation for making high-quality concrete is cement. Here, instead of the regular bags you find at the hardware store, they use much larger sacks called jumbo cement bags. Each one of these can weigh up to a full ton. Next, they add the exact amount of aggregates, fine sand and crushed stone in different sizes. A cool fact most people don't know is that these aggregates make up about 70% of the total volume of the concrete and significantly improve the structural properties of the final mix. Now, all the ingredients are thoroughly combined inside this industrial mixing machine. When the right amount of water is added, it triggers the chemical reaction in the cement, which acts like a molecular glue. And right at this moment, the clock starts ticking, because the concrete will gradually harden in an irreversible process. Finally comes the material distribution stage. In this critical step, the concrete is dispensed through this dosing valve, where the exact amount needed is calculated and sent straight into the mixer truck's loading hopper. So the whole process is technically known as wet mix concrete batching because it comes out completely ready to use on site. Once the drum is loaded, one of the most important and critical steps begins: transporting the concrete on the road. During this stage, the drum keeps rotating constantly to keep the mix perfectly homogeneous. If it sat still for too long, the ingredients would separate. The heavier stones would sink to the bottom due to gravity, and the water would rise to the top through flotation. That's the main reason you always see the drum turning, even when the truck is completely stopped at a red light or stuck in traffic. On the road, the drum only needs to rotate at about 5 revolutions per minute. The motion has to be slow but continuous to guarantee perfect homogeneity throughout the entire trip. But now we have 2 potential problems during transport that can ruin everything. The first is traffic congestion that can make the trip take longer than allowed. The second is when the truck is on a steep uphill or downhill slope. You'd logically think the concrete inside would spill onto the pavement because the angle is so sharp and gravity would do its thing. But there's a brilliant engineering solution to prevent that. And it's absolutely genius. All you have to do is significantly increase the drum's rotation speed. That's right. By speeding up the drum, the concrete is continuously pushed toward the bottom by centrifugal force, completely preventing any spill onto the street. But why does this happen physically? To understand it fully, we first need to see exactly what's inside the drum. And it's thanks to these helical metal blades. When they rotate in one direction, they perfectly mix the batch, and at the same time, keep the concrete at the bottom of the drum. When the drum rotates in the opposite direction for discharge, those same blades act as conveyors, continuing with transport. Something very important you need to know is that we only have a maximum of 1.5 hours to get the concrete from the plant to the job site. During this critical window, it stays fresh and workable. Once the trip is over, we have to make sure the concrete arrived in good condition. And that's when we perform the famous Abrams cone test. This test is done specifically to check the consistency and slump of the freshly arrived concrete. First, we take a fresh sample directly from the mixer truck and mix it thoroughly with a shovel so it's representative. Then we completely wet all the surfaces of the tools we'll be using. This is done so the concrete doesn't stick to the metal surfaces during the test. Now, we place this flat metal plate on the ground and set the metal cone on top of it. It's important to step firmly on both sides of the cone with your feet to prevent material from escaping out the bottom while filling. Now we start filling the fresh concrete in separate layers, tamping each layer with a metal rod to compact it properly. We keep adding more layers and tamping with the rod to remove all the trapped air inside the mix that could affect its strength. After filling the final layer to the top, we level off the excess concrete with a metal straight edge. Finally, we carefully lift the cone straight up without any sideways movement. Then, we place the cone upside down next to the sample and lay the metal rod horizontally across the top. Now, using a tape measure, we take the exact distance between the center of the sample and the rod. The measurement must match the type of concrete that was ordered according to the specifications. If the value is lower than the allowed tolerance, we have the option to add more water to the drum and remix at high speed. Then we repeat the slump test to verify. This test serves as a fundamental quality control and also measures the workability of the concrete. In other words, how easy it is to handle, place, and compact inside the forms. Once this quality check is passed, we move on to discharging the concrete at the job site. First, we spin the drum at maximum speed one last time, so all the ingredients blend perfectly. Listen to that powerful characteristic sound of the diesel engine and drum drive system, working at full capacity. If we look at the truck from the rear, the drum rotates clockwise to mix the batch perfectly, and counterclockwise to move the concrete toward the discharge chute. The internal spiral blades now function like an Archimedes screw and push the concrete outward gradually. And this is where another key piece of equipment comes in: a stationary concrete pump. These two machines work together on most job sites because the mixer truck discharges directly into the pump's hopper, and then the material is delivered exactly where it's needed, thanks to its long articulated boom. And for reaching even more difficult and elevated spots, we have this special accessory, a concrete bucket with an opening system. The mixer truck discharges straight into this metal bucket, which is then lifted by a huge tower crane. It has to be moved very carefully to avoid dangerous spills and prevent serious accidents. These lifting buckets are very practical and easy to use on vertical construction projects. They make it much easier to reach hard-to-access areas, like in this building that's outside the reach of the pump. For discharge, you simply pull a cord on the side. That opens the bottom valve so the concrete flows out in a controlled way. Now let's talk about the rotating drum and how it's manufactured. These are built to strict international quality standards. It all starts by shaping this thick, high-strength steel plate with an industrial hydraulic roller. And this way, we form its characteristic cylindrical structure. Then every section is welded, both the internal and external parts of the drum. This is an automated process because it requires millimeter precision. This guarantees excellent sealing, so none of the internal fluids leak out. The design of the internal blades is also crucial because they're key to properly mixing the fresh concrete inside the drum during transport. With the help of this 3D animation, you can clearly see how the particles are thoroughly combined inside. Once the welding is finished, the accessories are added, like the inlet covers, and then the drum is placed on its metal base. Then the complete structure is carefully mounted onto the truck chassis with the help of a crane. The drum is installed at an inclined angle, so it can rotate smoothly on its horizontal axis. Both structures are joined with high-strength bolts, but the interesting part is that these bolts have shock-absorbing springs. This is known as flexible coupling, and it reduces vibrations during operation and also structural fatigue on the chassis. Now, something very important to consider is that the drum can't be filled all the way to the top for two critical reasons. The first is because wet concrete is extremely heavy, about 2.5 tons per cubic meter. That means a fully loaded drum can weigh up to 20 tons without counting the weight of the truck itself, assuming an average drum capacity of 8 cubic meters. The other important reason it can't be filled to the brim is that it would become too unstable during transport. Like in this example, where the overload combined with uneven ground caused the truck to completely tip over on its side. Drum rotation drive. But now, how exactly does this heavy drum get its motion? For that, we have a specialized hydraulic motor located right behind the cab at the front of the drum. The system starts from this hydraulic pump that's coupled to the truck's diesel engine via a drive shaft and supplies pressurized oil to the hydraulic motor to keep it turning continuously. But here's something interesting from a mechanical point of view. This hydraulic motor isn't directly connected to the drum. First, it goes through a set of planetary gears that reduce the motor's rotation speed in exchange for much greater output torque. To understand it better, in this video, you can clearly see how the guy simulates the hydraulic motor's movement, and the drum turns much slower. This gives us the extra torque needed to rotate this heavy loaded drum. What do you think of this clever transmission system? We also have rubber shock absorbers at the front base of the drum. These help reduce vibration and small angular movements caused by the constantly spinning drum. And to control the speed and direction of rotation, we have manual control levers located on the side of the truck. With these, we can make the drum rotate clockwise or counterclockwise as needed. We can also increase the drum speed for fast mixing of the concrete. Additionally, we have heavy-duty metal rollers on both sides of the drum, and these improve power transmission and also serve as support points to hold the weight of the drum when it's fully loaded with concrete. So far, so good, but the constant operation of this system generates a significant increase in hydraulic oil temperature. To solve that effectively, we have an oil cooler mounted on the truck frame, and the heat is dissipated with the help of the electric fan at the rear. Dry concrete inside the drum. Now, what happens when concrete dries completely inside the drum? Believe it or not, this can actually happen when the material isn't discharged on time, and it becomes one of the company's biggest operating costs. A person has to go inside the drum, and this is possible thanks to a removable hatch on the side of the drum. The dried concrete inside has to be removed manually using electric jackhammers and other impact tools. You have to pay close attention to falling heavy fragments and be extremely careful not to damage the drum walls or the internal blades. If you're enjoying the video so far, please hit the like button and subscribe to the channel so you always get interesting and educational machinery content. Pressurized water system. Did you know this truck has its own built-in pressurized water system? Its water tank holds 400 liters and serves two important functions. The first is to add more water to the concrete mix if it's drier than normal according to the slump test. The second use is for washing the drum when it needs a quick clean before returning to the plant. But how do we pressurize this water tank? We have an air compressor coupled to the engine. You can see its location at the rear of the truck chassis. And to connect the pressurized air to the water tank, we use this control valve. This way, the water jet is much stronger and more effective. We also have a flow meter that tells us the exact amount of water added to the drum with much greater precision. Thanks to this instrument, there's no need to climb up to the hopper to see how much water is being added. Concrete test cylinders. You've probably noticed those small concrete cylinders whenever a mixer truck is near a job site. These are standardized cylindrical molds. A small sample of the mix being used on the project is placed inside them. They're left to cure for 24 hours and then taken to a specialized laboratory for compressive strength testing. That's right. These blocks are literally crushed and broken apart in a press. But first, they have to go through a curing phase underwater. for 28 days. This is done to ensure the concrete maintains the necessary moisture conditions for complete hydration and hardening. Once that's finished, the cylindrical specimens are placed in a high-capacity hydraulic press. Then, the load is applied progressively at a controlled speed. On this digital screen, you can see the pressure increasing until the first cracks start to appear in the concrete. Let's watch it again in slow motion. In some cases, the block can collapse completely in an explosive way. Finally, the results are analyzed based on the fracture patterns of the tested samples. This test verifies that the concrete used on site meets the structural design specifications. And if you made it all the way to the end, congratulations. Now, you're going to see a fascinating extra explanation about the big weakness of plain concrete. So pay close attention. Concrete by itself, even though it's very strong and excellent in compression, has one major disadvantage. It cracks and breaks easily under tension and torsion. As we see here, this sample breaks relatively easily when a bending force is applied because it lacks a property called ductility. Concrete is a very rigid material. To solve this, a couple of steel rebar rods are placed inside the concrete block to make it much stronger. And during the test, something interesting happens. Cracks start forming before the block completely collapses. This is the fundamental reason why corrugated steel rebar is always placed in every construction project, and arranged in complex, interlocking patterns. That's where the well-known terms reinforced concrete columns and beams come from. This gives the concrete the ability to handle many different types of loads. Accidents that can happen. Something very important is that the truck must be positioned on stable ground, especially when the surface isn't paved, to avoid accidents like this one, where the equipment got too close to an excavation. The combination of the truck's weight and the unstable soil caused the ground to collapse and the truck to fall into the hole. Other types of mixers available. This other unit is designed for smaller volume jobs and has a smaller, more compact drum. But the cool thing is, it has its own loading shovel, so it can supply itself with the concrete ingredients. And it can also tilt the entire drum base for easier discharging. On the other hand, this other unit comes with a built-in extendable boom on the same chassis. Even though it has less drum capacity, it's very practical when there isn't enough space for two separate machines to work at the same time. So you get the function of two pieces of equipment in just one. But what do you think? Is it better to use these trucks that already have a built-in boom? Or is it better to use them separately like in this case? Let me know in the comments. Thank you so much for watching all the way to the end and learning about the fascinating engineering behind concrete mixer trucks. Don't forget to like, share, and subscribe for more educational content on heavy machinery. See you in the next video.